This is John Wan. Today is November 11th, 2020. In today's video, I'm going to go through the research updates since the past week. As you can see from the Gantt bar stack, here I only have one item, which is deep learning workflow, so that I was able to be focused on this only research item for now. From the past week, was working on a plan, which is to implement the deep learning workflow in the data view system. And here is a figure that illustrates the structure of the implementation. Basically, it includes multiple tasks and as well as some logic. And here, for example, firstly, we have preprocessing data task, which is going to standardize the data. So for the machine learning, standardization is very important. And then we will go through a task which is going to split the training and testing data. And for the training data, which will be input into the neural network, and here we have a neural network start training task. That is a flag to tell us the training process is going to start. And here we always have a statement to check. That is to tell when the training process is going to end. And here we have the statement which is checking the epoch, whether it is smaller than, for example, 5,000. That means we're going to continue the training process, and we're going to go through the green arrow. And here green arrow will go to the linear layer task, and we also will pass an argument to the next task with the backpropagation equal to 0. That means we will always call the forward propagation method instead of backpropagation. So until we get to the last layer of the training process, we will go to a training end task, and this task will help us to set another argument, which is going to be backpropagation equal to 1 and point to the prior task. And this will help us to choose the backpropagation method instead of the forward propagation as we showed in the the green arrow. And here we always push back to the prior task until we get to the start training task. We will check the statement again and see if the epoch is smaller than 5,000. And furthermore, for every time we loop through this two-way training process, we will increment the epoch by 1. So until we reach the user specified epoch number, and we will go to the blue arrow, and this blue arrow will go to the testing task. Until now, we have already get a model that is trained by this training process, and with the testing data that derived from the former split task, and we will go into test the data with the existing model and get a prediction score. So that is a rough idea of the implementation in the data view system. So as you can see, for every layer, I'm going to extract 3 method many. So which is going to be the constructor, as well as the forward and backward propagation method. And here I haven't completed it yet, but here is a rough idea how I will implement in the code level. As well as in workflow level, here is one example for the simple neural network workflow, which is going to utilize a GPU. We are going to use the CUDA code via the JNI. And here we have several input files as input, for example, like the data, learning rate, number of epochs, as well as the shape of the linear layer. Later, while we have the convolution layer or other complicated layer, we will do the similar thing. And furthermore, we will stack them together in a design method, which is going to be adding the task into the workflow. Here, firstly, we add the preprocessing data task and split training testing data task, and then we have the flag task, which is the training start task, which is going to tell the training process of neural network is going to start. and then we have the linear layer, ReLU layer, linear layer, sigmoid layer, and then finally we have the end task of the training. And this part will go into many times loop, two-side loop in the former figure. So I'm still thinking about this challenge because we need to dynamically change the output port. For example, while we reach the training end task, we're going to point back to the prior task, and which maybe we are able to realize this in an executor's level. So for example, we can always check these two tasks, and then we're going to always check the argument whether it is backpropagation or not. We are going to choose the forward method or the backward method in each layer. So that is one solution. So that is what I'm thinking about right now. Maybe I will get better understanding while I move forward. So this is an example of the implementation. And for each layer, I will do the similar thing, which is going to be import from the DLL file, which is implemented in CUDA, and we are calling that from the GNI. But so far I haven't completed this yet, but most of them will have the similar structure as this one. So I think that is a plan to implement the deep learning workflow in the data view system for a single or a sample neural network. And for the second item, I'm still working on the coding to streamline the simple CUDA neural network in the workflow. And currently I'm trying to calling the CUDA from the GNI, but there sometimes has the type issue because we are going to use a matrix that is inside the data view, and we are going to convert the different types into the existing types we have. So that is one thing I'm going to working on, and I'm working on right now. So I think that's roughly the updates since the past week, and hopefully I can move forward further in this direction and get better understanding as I move forward along the way. So thank you so much for your time to watch this video, and hope you enjoy it. Until next time, happy coding.